Yeah. Okay. The last point we make on Friday, it was on the accuracy. Okay. Used to writing using pen. Okay, digital pad. So I'll write down here. Let me just recap what we have done. Okay, let's say I just quote one number. Okay, for example, I just quote 7.5. Okay, meter, and I give info. Okay, this has been corrected to 1 decimal place. So you're asked to find the lower boundary. Okay, I just write LB and upper boundary. Okay, so I know some of you are not familiar, you are not sure what to do yet. Okay, but I think majority of you know very well because you have done, okay, in your secondary school. Okay, so you see 7.5 meter is a measurement, and this is jot down. It means this has been corrected. Okay, this has been rounded up to 1 decimal place. Okay, this is the information we are given. 7.5 has been rounded up to 1 decimal place. Okay, so now above, I'm going to write down this 7.5, which we see now. Okay, this is what we see now. But before it was round up, it has a certain value, higher value, and also it has a lower value. Okay, so can I ask you, is it possible that this number here, okay, and this number here, this is on the lower side, we call lower boundary. This is upper boundary number. We are going to find these two numbers. Okay, so we question ourselves, could the upper value be 7.6? Could it be 7.6? Could this number be 7.6? Cannot. Okay. Sorry, I want to see your feedback. Okay, yeah, very good. Okay. I would always, my class always keep the right hand side for you to feedback. Okay, so if you don't understand, you got question, you should type in. Okay, because we normally don't speak because that cause interference. Okay, so you type in. So yeah, you answer correctly. No. Okay, you know why? If the original number is 7.6, after round up become what? After round up become, sorry, could it be, I made mistake, I made mistake. Could it be 1.56? Okay, could it be 1.56? Can the original number be 7.56? No. Okay, no. Why? If it was 7.56, no is correct. Okay? If it was 7.56, after round up, it become what? After round up, it become what? It become, can you round this up into one decimal? Yeah, good. Okay, it becomes 7.6, but our is not 7.6. Okay, after round up is 7.5. So this is not possible. Okay, how about I put down, is this possible? 7.51, yes, it's possible. Okay, and 7.54, is it possible? Yes. Okay. Now, so there is a point you have to understand. We call boundary. Okay, to the limit. Okay. So now, if I were to put down, is it possible that listen here carefully? Is it possible that this number is 7.55? Is it possible? Is it possible that this number is 7.55? Yes or no? If it is 7.55, after round up, it become what? It become, who want to answer? If it is 7.55, after round up, it become what? 7.5, 7.6, right? 7.6. But ours is not 7. It's not 7.6. Ours is 7.5. So even 7.55 is not acceptable, okay, in theory, okay. So there's this controversy, okay. You know, there's a convention. You see, when you reach a certain point, it automatic, after round up, you go to the right hand side, okay, the convention, mathematical convention, okay. So in order to avoid this, okay, in order to avoid this confusion, the other day I put down until 7.55, okay, but we must understand this sign concern, okay. So I want to put down here, we allow until 7.5 for 1 meter 9, okay, as long as it doesn't touch, 7.55, is okay, okay. So that is this point, it confuses people, okay. So I want to draw the line here, okay. I want to draw a number line to define it, okay. So I want to put down here, even though, okay, even though 7.55 in theory, technically is not allowable, okay? Because once it reached 7.55, after round up, it becomes 7.6, right? But ours is 7.5, okay? So that is why there's a trick here. We play with a number line, okay? We say, okay, let's say it is 7.5, and this one is 7.50. This is 7.55, and this one, this side is easy. Can you just tell me what is the answer here? Okay, good. 7.45. Okay, 7.45. So I put down a point. The lowest it can go is 7.45. Okay, and this one sure. This one no argument. Okay, so I darken this dot. Okay, 7.45 is the lowest it can go. Okay, but the highest point, I put a blank circle, okay? It means 7.55, just the particular lot not included, okay? So the symbol to represent, okay? The symbol to represent this, okay, is on the left I put dot, on the right I put a circle blank, okay? What I mean is this, I can give you one more example here, okay? Now, for example, okay, if I were to draw line, okay, let's say I put 13, okay, and we are told that this 13, okay, is the result of correcting to the nearest whole number, okay, nearest whole number. So we want to find what is the lowest bound and upper bound before you round up, okay? So what we can do is this, before you round up, okay, before you round up, you have upper bound and lower bound. What is the upper bound? Before you round up, what was the upper bound? 13.5, okay. But we tell people it doesn't include, okay? We tell people it doesn't include the 13.5, the dot itself, okay? It doesn't include. But this one, what is this point? What is this point? 12.5, okay. This is just to recap, okay? This is 12.5. So this one include, this point doesn't include. So it is the upper bound and this is the lower bound, okay. Now I just want to give you one more example on the what they call operation, combination operation using the upper bound and lower bound, okay, by giving one example on calculation, okay. Let's say I have this 10.4, okay, and this one equal to 8.1 and C equal to 3.2. Now, all of them all had been corrected, okay? All has been corrected to 1 decimal place. Okay, so you have to find out what's the upper bound and lower bound. Upper bound and lower bound meaning they are not yet round up, okay? What was their number possible, okay? Not yet before you round up, what was the number? The number given here, they are after round up already, okay? To 1 decimal, okay? So before that, what are they, okay? So now we will do it one at a time. We know 10.4 is the current value, okay? But before and after. So one of your friend reminded me about this one. Yes, I will put down here. Samuel is the one pointed out my mistake. Actually, my mistake. I shouldn't put here, okay, with the equal sign, okay. But then I was thinking that you may think it should be lower than. Afterwards, I put down. Then you understand what I mean. Okay, but actually it include that number only. Okay, because it's to the continuum. Okay, infinity. Okay, now can I quickly put down, since now you know we have seen many examples already. Can I put down the upper bound? Can I put down the upper bound? Yes. What should the upper bound be? Okay. Yeah, Samuel has put in all the number already. Okay. So yeah, 10.45. Okay. Now remember, even though we asked for upper boundary 10.45, technically 10.45 not included. Okay. That is why you put a less than. Okay. Less than sign. Okay, it doesn't include the equal sign, just less. But this one, yes. Okay, this one, yes. Because of the mathematical convention, anything that come to 5.5, okay, or the last digit 5, it should move to the right hand side. Okay, it should increase. But since we are putting upper boundary and lower boundary, you know what's upper boundary? What's the meaning of boundary? Boundary is an imaginary number, understand? Okay, imaginary number. It is used for us to spot the answer. Okay, it's imaginary number, boundary. So now, but this one is what? What's this? Yes, you put down already 10.35, okay, and etc. I just copy down quickly. So this is 8.15 and 8.05. Okay, so now with this, we are asked to find, okay, find the upper bound and lower bound of, let's say, A, EC1 plus B divided by C. Okay, so this one as a number. Okay, this one not separately like here. We want to see this as one number. Okay, so we want to see how to find the upper value and the lower value. Okay, so if we want to see this, the whole thing as one number, we try to, because it's in a fraction, we try to get the top part as big as possible, okay, and the bottom as small as possible, so that when the big might divide by small, we get a big number, the biggest number. Okay, so for the upper part, yeah, some of you so fast already. Okay, A plus B, we get the highest one and the highest one add together for the top. Okay, so it's 10.45 plus 8.15. Okay, and divide by what? 3.15. Why we divide by 3.15? Not 3.25. Why? Why we divide by 3.15? We choose the lower one rather than the bigger one. Why? Because when you divide, you must divide something small, so the answer is big, right? So the top one, we choose the big one. The upper, the bottom, we choose the lower. Yes. So that at the end, the final answer will be big. Okay, we want upper boundary, so it's the biggest possible. Okay? So now, so someone quickly work out the answer, and the same thing on the. Let us fill in this one. Can we fill in here? Okay. A, what should we do? A, what should A be? A plus B, what should A be? 10 point. Why we take the small one? Because we want to make small, okay? You understand? We want to make the top one as small as possible, okay? So, and then B also we choose the small, okay? 8.05. And the bottom one, can someone, what should the bottom be? What should the bottom be? C should be what? Okay. C should be, yes, very good, okay? 3.25, okay? We purposely make the top big, small, and the bottom big, so that when the small divided by big, the whole answer is small. Lower boundary should be the smallest, okay? Understand? So we will do some exercise, okay? We will do some exercise when it comes to tutorial, okay? So the answer I would copy down. I think, okay, okay. CD has put down the answer. Okay. Lim A1 has put down 6615. Okay, and the upper one is 59047. All this I will leave it to you to verify, to exercise, understand. So that the concept is very simple actually. Okay, it's about the what do you call accuracy. Okay, when you work out something, you want to find would it be other number? Yes, it could have been other result. So in this case the highest it can be is 5.9 something. The lowest it can be is 5.6 something. Okay, and it can't go out of this. Okay, it can't go out of this. So everything that we do, we measure in our life, they are not exactly, okay, they are not. They are within a certain accuracy, we call it, okay? In science, we call it tolerance, okay? Within a certain tolerance, okay? Okay, this is what we have done actually, okay? I want to move on to another very easy subtopic, okay? Now, we call it standard form, okay? We want to spend very short time on this. Standard form of number. Now, when you are given a number which has, okay, let us say I put down 5, 4, 3, 8, 2, okay? It could be even a bigger number, okay? So, if you have a very big number, okay? Now, we always like to put them into the standard form. Now, what do you mean by standard form? Okay, standard form is to make sure, okay, that the number we have is expressed in this form, which is, okay, standard form uh, is the front number must be, okay, the front number, okay, it must be less than 10, okay, upper more than or equal to 0, okay. So the standard form must have a number, okay, in front which must lie between 0 and 10, okay. If it exceeded 10, it's no more standard form, okay. If less than 0, is no more a standard form. You understand? Okay. So then we play with the exponential term here. Okay, 10 to the power. Okay. So our job is very easy. How to put the power? So we assume point here. Okay. We assume a point and we start to count how many times it has to be moved out, okay? How many times? So we assume a point here like that, what you put 5 point, okay? We assume a point, then we move 1, 2, 3, 4, 4 times. So in other words, this number on the left and the number on the right, they are that the left has been expressed in standard form already. This is standard form. Can I ask you, how can I call this, why I call this a standard form? Why I call this a standard form? Anyone? Why? Why is this a standard form? Because of this, okay? The number, you can call this a coefficient, the front coefficient, is in the form of more than 0, less than 10, okay? So if you can express any number, make sure that the front one is more than 0, less than 10. Then that is the standard form. You understand? Okay? Okay, we want to just quickly jot down one more example. Okay, so if I want to put this one into standard form, okay, let's say I want to do 3 point, okay, 123.56. Okay, I want to write this in standard form. So what should I do? Okay, so basing on the game, the rule of the game, they say, okay, the first number must be 1.2356. Okay, no deal. Okay, it must be like that. Okay, if you put other number, wrong already. You understand? It must be between 0 and 10. Then only is standard form. Okay, so this one quickly put down. But then times 10 to the power of what? Okay, so the what is here. Is it 1? The point is here, 1 point something. So you locate that point here, okay, 1 point something, and you move how many times? 1, 2, okay? You move 2 times so that it come to the decimal point, okay? So you move 2 times. You understand? Just now, you see, 54382. It has no decimal point, understand? But if there's no decimal point, we understand the decimal point is on the end, at the end. Okay? There's no need to write decimal point. So we move from here 1, 2, 3, 4. We have moved 4 times, 4 steps. That's why the power is 4. You got it? Okay? And let us quickly jot one more time because we have other thing to do. Okay. So what happens if I got a small number like that? Okay. Okay, very small number. It could have been even smaller than that. Okay, doesn't matter. So I got no choice. I must also put it like that. Okay, so that it is standard form. Yes, yes, yeah. Many of you got it. Okay, I'm happy. Okay. So we want to see what is the power. Now, in order to move to here, this is what we want. Okay, this is what we want. Just now it was here what we want. Now it's here what we wanted. So we must move 1, 2 times. But now we move from the target to the original. We move leftwards. So it is negative. Okay, you move to the left. Okay, so that's what negative. So, but in short, okay, now look here carefully so that we will not make careless mistake. Okay, if you see the origin number is more, okay, it is more than 10, then the power, I mean, it's more than 1. If the number is more than 1, automatic, the power is positive. Okay, positive. But this is less 0.01. So the power will be negative. And then negative what? Depend on how many times you move. Understand? Like here, positive, positive what? It depends on how many steps you move. Okay, we move just now 2 steps. Okay, firstly is positive. We know it's more than 1. So the power is going to be positive. Okay, and here the number is less than 1. So the power is going to be negative. Okay, so let us take just one more. Okay, and we can move on. Okay, we can move on. Okay, Muhammad Saad say, I don't understand part 2. How? Okay, I want to explain this one. Okay, part 2. Yes, Wei-Huan has the answer. Now, Muhammad, look here, look here, look here. Okay, now we are going to fill in one number and the power here. Okay, the power here. Firstly, the power is a negative. I can put down negative. Why? Can you answer, Muhammad? Why the power is going to be negative? Yes, we move, okay, backwards, correct. But the negative is confirmed by the size, okay, less than 1, okay, less than 1 automatic is a negative, okay, because this number is 0.00 something very small, less than 1. Whenever less than 1, the power going to be negative. So you put a negative to confirm, I mean to make sure you don't make careless mistake. Okay. The second one, this number has no negotiation, no due. you must put down no other way. Okay, standard form. It must be 5.27. Okay, you cannot change this number. Okay, because it's standard form. Okay, and now you are putting here already, right? Then you ask yourself how many steps you have moved. Okay, so you have 1, 2, 3, 4. So you must put -4. Okay, and this is the answer already. Got it? Okay, can Anna? Okay. Okay, anyone got any question? Can you put down on the right hand side? Okay, okay. Now I just randomly give one more example to recap, and then we move on. Okay, we move on. Actually, very easy. But mathematics is something if you learn, then you know. Okay, if you never learn, even though easy, because you never learn. So it's okay to ask questions. Okay, so let us just put down a simple question like this. Okay, okay. So now, how to do this one? Very easy. The last term must be positive. Why positive? Why positive? Very good. Okay, this is 100, 300 something, more than 1. Okay, more than 1. So it's automatic positive here. How many steps we just count? Okay, so the first number must be this. Okay, no due. Okay, standard form. But we want to see it has moved. How many times it has moved to become 3 point something? How many times? How many times I move? Yeah, 2. Okay, so so this is the answer. Okay, I think we close this one. Okay, yeah, we move on to the next one. I think it's more interesting. Okay, now this is called number system. Okay, number system. You see, we are interested in the decimal, okay, system, okay, or we call it base 10, okay, the base 10 number, okay. Now base 10 is what we use every day, okay. This is the most important system, number system we learn, okay. Now according to scientists, they say decimal number is what we do. I mean, every day we use decimal number, okay. The base 10 number, because human being got 10 fingers, okay. So first they go to shop, they say, oh, I want eggs. They got no language, so they use hand. I want eggs. So the shopkeeper take 4 eggs. Okay, 4. 1, 2, 3, 4. Okay, so they can show, and then they can manipulate to other ways to show 30 or 100. Okay, but it takes time. Okay, because they are not very scientific, mathematical inclined. Okay, but later on mathematics develops, okay, science develops, so everything change, okay. So we will go into this very fast, okay, in a short while. Now the next most important one, decimal, meaning base 10, okay. It is binary, okay, system, okay. So it's called base 2. By meaning 2, okay, binary system. And then we got octal system, base 8, okay. In modern usage, we are more computer inclined, so we use base 2 and 8 and also 16. So you got hexa decimal, okay, base 16. Okay. So we want to discuss all this because they are all related. Okay. Now, if you understand even the base 10, how it works, then you understand all other base. Okay. Very simple. Okay. They follow the same principle. Okay. The same principle. Okay. Now, those online. Okay. Yeah. Very happy that you all take interact, okay. Because not like the physical class 2 years ago or 1.5 years ago, okay, we never go into online, okay. But everything on the board, okay, on the board, and student, I can see, I can work there, but now I can't, okay. Even if you sit at home, you sleep, I also don't know. So I hope you can interact, ask questions, so that you know what, so that those who are fast learner, or they have learned, okay, uh, then I understand, okay. Those who are new, okay, not that you are not so good, but you are new, okay. Then you also voice out, then I know, okay. Otherwise you keep quiet, I'll just move on, okay, move on, okay. Not like physical class, I can see the reaction, I can interact, I can walk to your place, okay, and I can call you, and yeah, but now cannot. During physical class, I can show sign and etc. But now I can't. Okay, I got no much weapon, okay? Physical class, I can shout and I can bang table, etc. If I bang it now, they say this crazy old man now, bang table, okay? Because they don't know the story, the setting, the environment, okay? Okay, now I want to point very carefully here, okay? Remember, I'm going to repeat uh, the same sequence, the same approach for all other base, okay? So you need to understand one base, okay? And it's a repeat, so simple, okay? It's a repeat. So now I want to start with decimal base, okay? Which all of us know. Okay, decimal system. Okay. Now this is called base 10. So you see, I'm going to put down some number here, okay? It is not that I think you don't understand, okay? Of course, you use this every day. You are expert already. But I just want to borrow this for other part later on. Okay? So I'm going to write down uh, here, okay? So here we have value, okay, of digit, okay, the value of digit on the here on the left hand side, and here I'm going to put down a value of the number, okay. First, in our decimal system, we use digit, okay. Let's say value 1, 10, 100. Can you guess what I am going to write down? The first digit from the right, it has a value of 1, okay? Now, for example, here, okay, I'm going to put down 4, okay, and 5, and 8, okay? Now, this the value of the digit, okay? This 4 has what value? This 4 has what value? This number 854. 4 has what value? 1, right? Huh? I have written down up here. 4 has a value of 1. Okay, the position is 1. Okay, 5 has a value of what? 10. Okay, 5. So what I say is 4, 1. Okay, 4 is a unit position. 1 means unit. Okay, 5, what is the position value? 10, right? Huh? 5 represent 10. Okay, 8 represent what? 8 represent what? Yes, 100. Okay, good. Okay, and if I were to put down another, what do you think will be the value of the digit? Okay, 1,000. Okay, 1,000. Okay, so now look here. So you see, the system is like that. You already know. Okay, you already know. You know, I read a number 2854. Now, each of these has a value. depending on the position. 4 is on the right, okay? The first position is unit, okay? So, and then 5 position 10. So it's 5 times 10, okay? 50. So this 5 means 50. This 8 meaning what? 800, okay? This 2 means 2000, okay? This 4 means 4. Okay, 4 times unit means 4. Okay, so each of them has a value. Okay, each of them has a value. Okay, now this one I just put 10 because it's system 10. So power of 1. Sorry, power of 0. Okay, let me draw. So this 10 has a power of 0. Okay, this 10 is 10 power of 1. Right? 100 is 10 to the power of 2. And 1000 is a 10 power of 3. So if you look at the power, then it's nicer. Okay, 1 minus 10 to the power of 0. So the position is 0. The position is 1. Position is 2. Position is 3. Instead of looking at 1000, I look at the 10 power 3. It represents the fourth position and etc. Okay. Can I put, okay. So what is the, okay, let me put down here. The digit used. In decimal number, what are the possible digits that you can use? 0, you can use one, you can use 0, you can use 1, you can use 2, 3, 4, 5, 6, okay, 7, 8, 9, okay. So in writing decimal number, okay, in writing base 10 number, okay, we can use all these digits, okay, we can use all these digits, but there's no 10, okay, it one round 9 already full. The next number is, so repeat of 0, 1, 2, 3, 4, okay, you understand, okay. So in system, okay, in base 10, we can only use 0 until 9, okay? No number 10. 10 cannot be used, okay? 10 will be repeated, okay? When come to 9 full already, the next number is 10, okay? 10 is already up here, okay? So in system 10, can I ask you, what are the number used? What are the digit used? In system base 10, what are the possible number used? Is 0, 1, 2, 3, 4 until 9. Okay, and now I jump. In base 5, what are the possible number used? 0? Okay, until 4. Good. Okay, in base 5, you can use until 4. Okay, no such thing as 5 there. Okay, in base 16, what are the possible number? In base 16, yeah, 1 until 15. Okay, you can use number 1 until 15. Okay, now we will come to that. Okay, so now look here, I just want to list down, since you know the value. Okay, this 2 has very high value. Okay, so just now you already say 2. Okay, this represents 1000, so 10 power 3. Okay, and this 8, okay, it has a value of 100, so power of 2. This 5 has a value of 10. Okay, and this 4 has unique value, so 0. Okay, 10 power 0 is 1. Okay, so if you were to multiply, of course there isn't need to multiply. If you multiply out and add up, okay, you get 2854. Okay, now you find this question is so easy, but if you go into octal system, the same thing. Understand? Because we are used to this, then we say, oh, it's just like that. 2854, the 2 has the highest value because it has a position of 1000. Okay, 8, it is a position of 100. Okay, so all this front number has very high value. I I don't care whether my salary at the back, God don't know, I don't care whether it's 8 or 9 or what, I don't care. But the front one very important, okay? Because it carry high value. You understand? So the same thing happen in other system, okay? The front one, they carry their high position, the position value very high. Okay, you understand? Okay, so we are going to use this logic for other number system. Very, very simple. Okay, so now, okay, I think the decimal system, we don't want to spend more time, okay, because it's very easy. Okay, so we want to use this one as the starting point for other number to convert to, because we are more familiar with decimal number. So other system we convert into decimal. Okay, okay. So what I do is I want to start another system. Okay, I call it uh, base 2. Okay, I call it binary. Okay, binary system. Okay, we call it base 2. Now base 2, of course, since it's base 2, the possible number are 0 and 1, right? And there's no 2 there. Okay, just like in decimal system, the possible number is 0, 1, 2, 3 until 9. Okay, here base 2, it has 2 number. What are they? 0 and 1. Okay, there's no 2 there. Okay, so you play with 0 and 1 and you can show a value until median also, but just play 0 and 1, okay, to show very big number. Okay, okay, now so what I want to, decimal is a very simple one. We can do the same thing here. Okay, do the same thing. So the first position, okay, has a value of 1. Okay, I straight away put 2 to the power of 0. Okay, the second number has the power of 1. Okay, base 2, I put 2. The third number to the front has power of 2 and etc. Okay, so depending which position you are, okay. For example, if I tell people, oh, my salary here, because I cannot use other number, it's only 0 and 1, okay. So I got 1, 1 here, and got 0 and 1. How much is this? Okay. So in the language, now in our normal language, okay, in our normal language, this one means 1101. But in the decimal language, sorry, in the binary language, this is very small number only. Okay, very small number. Okay, so let us look at the value now. So this one, it means 1 times 2 power 3. Okay, this one meaning 1 times 2 power of 2, because the position is 2 power 2, okay? And this 0, although 0, but still write down, okay? 2 power of 1. And then this 1 is 2 power of 0, okay? 2 power of 0 is 1. So we can quickly get the answer. So it's 8, okay? This is 8. This is 4. And this one nothing, okay? Because 0 times whatever, nothing. And then this one is 1. So what is the answer? What is the answer? 13 only, okay? 13, okay? If I tell you that you will get a pay of this 1101, don't be too happy, okay? Your pay is only 13 if you convert into decimal, okay? So in decimal number, okay? So it's only 13, 1102. So in order not to confuse people, okay, whenever the number is base 10, we can put 10 is a subscript, okay, and this is base 2. We put a 2, small number, so that people not confused, okay. People will not think it's 1000 something, okay, because it's the decimal number. We put a small 2, a subscript to tell people the system, okay. So we can do some exercise now, okay. Okay, maybe I should give you a break, okay? So that you can go relax a bit, go to toilet, and okay. So let us take. What should the time be? Okay, now 9:45. Okay, 9:45. We come back. Can we? Okay, 9:45. Yes. And for those who not yet mark attendance, those who came late for some technical thing here, okay? So I cannot go show, okay? But that Friday we got a projector booking, okay? So now you come here, very sorry. It's just like you stay at home. It's online, okay? You cannot see that, okay? But what you see on the screen is like what you see in the computer, exactly the same. Okay, so I will put the attendance. Okay, I put your attendance. Those of you not just scan, you can scan from there. Otherwise, I can not manually. Okay, yeah, if you can scan now. Yeah, you can take a break. Okay, I know sometimes not because of difficult, but sit down and boring. Okay, get relaxed a bit. Okay, I know many of you may have learned this in Chinese. This is sub sui, but what to do? You some are not yet. Okay, some not yet learn. Okay. Because their education system different. Okay, they are different. Okay, for those who are not yet marked, I mark manually. Okay, I mark manually. Dalam, dalam. If you are in, you just say in. Just say yes. Okay, I will mark. Sangha, Sangha, are you in Sangha? Sarda, Sarda, Thong Ching Yu. Okay, they are, I think, the brothers. Ching House in. Okay, class, we are back already. Okay. Let us continue. Let's continue. Now, just take one example. Okay, very quick one. So, let's say I have a number. Okay. Okay, actually, very big. What is so-called very big number, but the value may be very small. I tell people that it is system 2. Okay, so I start convert this into our base 10 number. Okay, so we start counting carefully. Okay, now this number has a value of 2 power 0, power 1, power 2, power of 3, power of 4, 5, and 6. So there are different position. Okay, the highest one, of course, just like our normal number, the front one has a biggest value. Okay, in terms of the digit position. So yeah, some of you so fast already. Okay, very good. Okay, so then we write down using calculator. This one, yes, 1 has a value of 6, 2 power 6, and then 5, 4, and 0, 0. This one, no. So I can skip, and then 2 power 1, and then 2 power 0. Okay, there's also 1. Okay, so of course this is 1, this is 2. Use your calculator. Okay, 2 power 6 plus 2 power 5, etc. So I suppose, yeah, one Samuel has 115. Okay, so you can use your calculator to convert. Okay, to convert. So we know actually all system doesn't matter. Some system are not important because of the modern, the modern world. We have a binary system. Okay, we have octal system, hexa, octal, and hexadecimal system. They are all computer related. That's why they are important. Okay, so it doesn't matter what system, we can easily convert them into DESI system. Very easy, like what we do now. Okay, even if it is octal afterwards, you can do the same thing. Okay, close our eyes, just do the same thing. Calculator help you. Okay, but now I take this opportunity to convert backwards. Okay, now convert. Let me put this under B. Okay, B. Okay, converting. Okay, we want to convert. Just now it was binary to our decimal system. Okay, from system 2 to system 10. 10 is what we want. Okay, every time. But now I change. Okay, from decimal system, it means base 10 to binary. Okay, so this will be just the same method if you go to other system, the same thing. Okay, so I want to convert from our base 10, this is our usual number, okay, to base 2. Okay, so how to do that? Okay, so we only want to do once, then you understand what to do for other. Okay, so we can also change your base 8 later on. Okay, base 16. Okay, they are the most popular one. So now we do this one. Okay, we do this one. Later on, the others same pattern. Okay, so in maths and science, you do something, but you apply to so many things. Okay, if you understand the principle behind. Okay, so we're going to convert example here. Okay, example, if I want to convert 5, 3, 4, 1. Well, this one looks 1,000, but after converting the number very, very big. Okay, maybe I cut down. Just want to show you the method only. Okay, so the digit won't be too long. Okay, so now if I want to change, this is base 10. Okay, I want to change into base 2. What should the number? I'm sure the number will be very big. Okay, I mean long number. Okay, okay. What we do is I divide. Okay, the common method. Okay. Okay, how to do this one? We start by this method, and it's going to be used later on. Whenever you want to convert system 10 to whatever number, you divide by that number. Okay, so now we'll change it to we divide. Okay, we are using long method. Okay, long division. Slowly, it's okay. Okay, so we divide. You see, divide system 2, so you divide by 2. Okay, so be careful, okay, to avoid careless mistake. So you divide 5 divide by 2. Okay, slowly, yeah, we got 2. Okay, 2 times 2, 4, but here got 5. So got 1 extra, 1 remainder. Okay, so 1 bring over become 13. So 13 divided by 2 got 6. 6 and 2 only 12. Here 13. So got 1 more. And then, so it's 14 now. 14 divided by 2 because 7. So there's no remainder. So you put a 0 there. Okay? There's no remainder. This one is important for you to collect the points afterwards. Okay? So you put no remainder, 0. Okay? So now you continue to divide. Remember, divide by 2 every time. Samuel has the answer already. Okay? So now, let us divide. So got 1, and then got 3, no remainder, no remainder. 7 divided by 2, we got 3. Now we got 1. Okay? So be careful. Continue. Okay? 1 cannot, so I get 13, so 6. Here also 13. 1 remainder. Okay? As expected for the number so long. Okay? Now mind, just be careful. So 3, no remainder. Be patient. Okay? Divide carefully. 6, 1 remainder. Okay? Make sure you put the remainder carefully, correctly. Okay? Here got 8, no remainder. 4, no remainder. Luckily, I cut down, otherwise I had to write a lot here. The more you write, the possibility of careless come in. Okay? And 1, no remainder. So you divide until nothing. Okay? So 1, remainder. Okay, so how to write the answer? Yeah, from bottom to the top. Okay, very good. Okay, you have to list down your answer from bottom to the top. Okay, be very careful. So make sure that you divide until 0. Okay, until you cannot get, and 1 is the remainder. Okay, until then you convert, you write the answer from bottom to the top. So yeah, correct. Here Samuel has the right answer. Okay, there. So so the answer would be, okay, never mind, I just write here. Okay, so the answer is 1 0 0 0 0 1 0 1 1 0. Okay, so it is a system 2. So this is the answer. Okay, although this look very big, the number seems very big, but it only represent 534 in our normal value system. Okay, this only 534, 500 something. Okay, if you convert, because it's the very low value system. Okay, very low value system. You understand? Okay, so we have to divide. Okay, you have to divide carefully. Okay, even though they want system change to system 5, system 5 has no use in computer. Okay, computer application, but just for fun, you can change the system 5 by dividing 5, and I say, and do the same thing. Okay, so after learning one method, you apply to many. Okay, okay. Now I want to go to maybe just this another system. Then we can see some shortcut. Okay, we can see some shortcut. Maybe I want to go to my system octa, okay, octa system. Okay. So it's a base 8, okay, base 8. So straight away I want to write down, okay, if I want to convert, because make sure that I recognize, I purposely put something here and you tell me, is this system, is this number correct? Is this number correct? Ah, good, very good. Okay, this number is wrongly written. Okay, good. This number doesn't exist. Okay, in the base 8 system, this one doesn't exist. Okay, because there's no 9. Okay, in the base 8, 9 doesn't exist. Okay, so it cannot be found, cannot be calculated. So now take another example. Where I hold on, I try to bring this down. because I have written into this area, I cannot. Okay. I open another. Okay, let me come here. Okay. So I want to convert. Okay, let's say I want to convert this number into system octal. Okay, I'm sure this one is valid already. Okay, this one system 8. Okay, so very quickly convert this into 10. Okay, convert this into 10. So we know this one has position of 8, 8, not 10, because it's system 8. So 0. This one has 8, 1, 8, 2, 8, 3. Okay, so the answer is 7. The value of 7 is this, 7 times this, and then 6 is, I always write 10. Okay. So make sure that you have the position value correct. Okay. Power, the the rightmost has power of 0, 8, because system 8. So all are 8, the base is 8. And then the power just increase in sequence. Okay. So you do this using your calculator. Okay. And yeah, Stemmer has the answer there. 4002. Okay, this is our system 10. Okay, system 10. The same thing, we want to convert. Okay, okay, just convert. Okay, this is system 8. Sorry, let's say system 10. I want to convert into 8. Okay, so if I convert into 8, I divide by 8. Just now we divide by 2 because we want to convert into system 2. So can you divide by 8? Divide by 8, get the answer. Okay, divide. Okay, divide. System 8. So we got 6, 7. Okay. And then nothing. So 6. Okay. Yeah, good. It's just a practice. I think all of you can do it. Okay, go home. You will just try as many exercise. When we come to a tutorial, we'll do that. Okay, so we would a lot of opportunity. So you see, I usually don't follow PowerPoint. Okay, PowerPoint for you to just read to exercise. Okay, for all my classes, okay, even the masters, okay, I teach most of my time with the master class. I do like it, okay, because the PowerPoint is for them to read, okay. You know, as far as mathematics is concerned, there's very little need for you to read book, okay. There's no, I mean, my subject, statistics and maths. Our friends, you are all my friends, just need to understand and very detailed. Need to go to library, mathematics, how to go library, okay? There's no need to read books, just understand and exercise, okay? We have a lot of exercise in the tutorial, okay? So we will go to the tutorial, okay? Only for maths, okay? But my other subjects, I don't really do tutorial. My class is tutorial actually. I do little bit theory then exercise. That is a kind of tutorial. Okay, okay. So let us go to. So I think you know how to convert. Okay, 10 into whatever system. 2 you divide by 2. 4 you divide by 4, 5 divide by 4, 5, okay, and etc. Okay, but there's a need for us to go into the next one is system 16. Okay, a little bit different from others, just very little different. Okay, system 16. Okay, we call it hexa. Hexa means 6. That's C. Okay. Okay, Tong Ching How asked how you got 440. Okay, let me see what I asked. Oh, okay, how I got 440. Okay, look here. Okay, I divide. Start with 3. 3 cannot divide, so I get 35. Divide by 8. I got 4. 4 times 8, 32 only. So I got 3 left. So 3 together with 2 is 32. Okay, 32 I divide by 8, I get 4 again. Okay, nothing left. So 1 divided by 8, I get 0. Okay, and there's a remainder of 1 because there's 1 here. 1. Because just now everything used up already, only 1 left. So 1 divided by 8, I get nothing. And this 1 become the remainder. Can? Okay, Ching Hao, you got it? Okay, good. Yeah, any very good. If you have anything, you please ask. Okay, please ask because I'm actually I teach online. I'm quite scared also because I cannot see you. I if you keep quiet and even if you do just on and go off, I also don't know. Okay, so uh, the only way is to ask question. If you don't understand, okay, can ask. Okay, let us go to hexadecimal. Okay, so hexa means 16. So it's a base 16. Okay. Now base 16 actually, as we know, you see, from the beginning I set up a kind of repeating for all of us. When you go into other system, that the same thing repeat. Okay, so you see, you also answer correctly just now. When base 16, we only use until number 15 only. Okay, until 15. So 6, 7, 8, 9. Let me write out 10. Okay, actually it doesn't go this way lah, but we put down first. Okay, let me squeeze in so that it don't look messy. I write down the number. Okay, it stop at 15. Okay, but you know, there's confusing if you put 1, 5. I mean, basically, you confuse it with system 10 because until now the rest is just 1, 0, 1, 1. It doesn't use, but in order to avoid the confusion, okay, this number onwards we convert, okay, we don't use 10, okay, we use A, okay, we use alphabet, which you already know, okay, so 10 means A, okay, unless next time you are expert in your area, you invent your number, understand? It's okay, it's okay. But people already say 10 means A, then B, so easy to understand, okay? This one C, this one D, E, and this one means F, okay? In order to avoid confusion of 1, 0, okay? 10 means A, okay? So in a way that this base 16 used until 15, there's no such thing as 16. There's no such thing as FG. No G appearing, okay? That is what the system, okay, number system. For decimal number, we use until 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, no 10. Okay, here no 16. Okay, then the whole story repeat. Okay, the whole story repeat. So if I want to convert, okay, to A, and then 5, 8. I don't want to put too big number because it's 16. It looks so few, but a very big number. Actually, the value very big. Okay, let me just put 0. Okay, so that is system 16. So I want to find what value it is. Convert into 10. Okay, so as usual, okay, as usual, I must know the position, each of these, what are the value they represent. Okay, so this is 16, you know, 16, huh? So they are all base 16, so 0, 16, 1, 16, 2, 3, 4. Okay, so each of them has a value. The front one higher value and etc. Okay, so let us work out quickly. Use your calculator. Okay. and then A. Okay, now A means what? 10. So we be careful what A means 10 because we want to change into our system 10. Okay, A means 10. Okay, so use your calculator. This is nothing. Okay, this 8 times 16. So use your calculator and yeah, okay, okay, Wei-Han and Samuel same, okay, same answer. So I can trust them because same, okay, two answer reconfirm each other, okay. So we can bet they must be right, okay, and yeah, Shitter same. Okay, all the answer come out same. Unless got different answer, then I have to reconfirm. Okay, so this is correct. Okay, but anyway, try to do not really understand the method of the system. Okay, okay, Jing Yu. Let me go back to octal system. Which aspect of octal system? Whatever system, they are the same. You mean convert octal system to our 10, is it system 10? Okay. For example, this example, is it this example? Or the other, okay, both. Okay, let us look at this example first. Okay, this example. Now, if you have octal number, this is octal number, the system 8. You want to convert this number 7642 into our ordinary number, okay? So we have to look at the digit. Each digit has different value. Okay? This 2 is in the position of 8 power 0. Okay? Now, just like if I write my ordinary number, okay, Jing Yu, look here, okay. In our ordinary number, okay, if I buy something, the cost is 54,321. Okay, this is 50,000. 5 means 50,000. 4 means 4,000. 3 means 300. 2 means 20. 1 means 1. Okay, so you see they are each of the digit they have different value. Okay, they got different value. Okay, I can write them into power. Okay, this one has a power of 0. 2 means 10 to the power of 1. So the power is 0, 1, 2, 3, 4. Okay, 10 to the power 4 means, so 5 means 50,000 because 10 to the power of 4, okay, is 10,000. This 4 has value of 10 power of 3. Okay, this 3 has power of 2, means 100. So 3 is a value of 100. 2 10 power of 1 means 20. 2 means 20. 2 times 10 power of 1. Okay, so all this digit has value in terms of power of 10. Okay, 10 power 0, 10 power 1, 10 power 2, 10 power 3, 10 power 4. In case you are worried that you may confuse them, all number system always start from power of 0, 1, 2, 3, 4. Okay, so now you borrow the same system because this is system 8. So the power also 0, 1, 2, 3, but the base are 8. Okay, you want to find this one. What is the value of this? Okay, the whole thing. The 7 is a position of 8 power 3. 6 is 8 power 2. So you take them separately and add up using calculator. Okay, using calculator. Understand? Ching, are you there? Okay. So if you were to convert system 8 into 10, you do like that. But you convert the opposite way. Okay? If I got system 10, okay, 3,521, I want to convert into system 8. So if I want to convert into system 8, I divide by 8. Okay? If I want to convert into system 2, I divide by 2. I want to convert into system 5, I divide by 5. Any number, just divide. So this example show how to divide, because 10 is our ordinary number. Okay, I want to convert into 8, so I divide by 8. So you just need to be careful when you divide. Okay, just take the remainder and the answer come out. Okay, so okay, maybe during tutorial, okay, we can do more. Okay, tutorial. Okay, so now come back to this one. Okay, we managed to convert 2 A means 10, 2 A 580, but it's in the system 16. So we're going to convert into system 10. Okay, this is system 10. So it looks a lot. 173,440. Okay, so this value. And how about if you convert the opposite way? Okay, if you want to convert ordinary number into system 16, so you divide by 16, just like that. So when you divide by 16, same method. So be careful. Look out for the remainder. Okay, be careful. So we'll do that. Okay, because the same thing repeat. Okay, we'll do that in the tutorial. Okay, but now I want to combine all the system. Okay, see some shortcut. Okay, maybe you say, okay, can I ask verbally? Now listen here. If I want to convert system 2 to system 10, what should I do? So I look at a system 2. Each digit has a value and then just multiply. Okay? If I want to convert system 10 to system 2, what do I do? You divide. Okay? Because system 10 to 2, you divide by 2. Okay? But the trouble is, what happens if I want to convert system 2 to system 4 or system 2 to 8? then there's a shortcut. Okay. Okay. So let me give you example. Okay. So converting. Okay. Okay. Interconversion. Okay. Wow, so far already done. Okay, interconversion. Okay, of base 2, base 4, base 8. Okay, and base 16. Okay, especially among them. Okay, so we can save a lot of things. Okay, for example here. Yes. Okay. Yeah. One method is like what David say. Change them into 10 first, then 10 into whatever you want. Okay. But there's a shortcut. Okay. There's a shortcut. Okay. So even right now, without shortcut, you can do already. Okay. Like what David say, whatever base, you change to 10. So with a 10, you can change whatever base again. Okay. So for example, like I have a number. For example, I got 1, 0, 1, 1, 0, 0. So this is system 2. Okay. I want to convert into system 8 or system, okay, system 8. So how to do this? Okay, so you can do a long method. Yes, Wehan got the idea. Okay, I think he must have done in secondary school. Okay, never mind. We don't treat anyone has done already. Okay, never mind. Okay, so what we can do is we can use one method. Okay, we convert step by step. Okay, we convert into system 10 first. Okay, okay. Then from system 10 we can convert into system 8. So to do this, we get this on 2 steps. Okay, first system 2 you were asked to convert into 8. Okay, so what you do is system 2 convert to 10, then from 10 into 8. All this you can do, but of course like Wei Huan say, we can have a shortcut, very easy. You can do in few seconds. Okay, so I will leave this one to be done in the tutorial. Okay, you can go backwards also. Okay, system 8 to 2 very fast. Okay, or system 16 to 8. Okay. They are easily done because their base are power of each other. Okay, not exact power, but they can fraction of power, etc. Okay, so that is what it can be done. Okay, very fast, few seconds. Okay, so I think it's time's up because you may have other class also to take care. So I think I will stop here. Okay, I stop here, and our next meeting will be when we have tutorial already. Okay. Okay, so I see all of you. Okay, bye bye.